Hello and welcome. So in this video I'm going to talk about lists in Python. So if you've learnt another language that uses arrays or array lists, then lists in Python are similar in functionality to those. However, you don't have to set the size of the list, so it's a bit more like an array list, and there are some other differences as we go through. So if I open up idle and I'll create a new window, and I'm going to copy and paste 4 lists from a text file in here, and we'll see that the first list I've called number list, so this is still a variable. It is before the equal sign, so the list itself is stored in a variable. So I have number list, which is just a list of integers, so we'll say list of integers, and then I have one called decimal list, which is a list of floats. All of these are floating point numbers. 0.0, because it has the decimal point there, it is still a float. This would not register as an int. And again, because these are numbers, so integers and floats are all numbers, you don't need to have the quotation marks around them. In fact, if you did have quotation marks, then it would turn it into a string, as you can see by the green highlight. So I then have a word list, which is just a list of strings, so we'll add that in. And then I finally have a bool list, which is just a list of booleans, if I could spell. So unlike with an array where you might have to set a particular size, with an array in some languages you wouldn't be able to add any more numbers, for instance, into this array here, unless you had specified that it was going to be a set size, or you would have to create a new array, copy these values in effectively, and then add others into the new array after these ones. And in languages that have an array list, normally you can only have one data type in that list. So you can either have integers, or you can have floats, or strings, or Boolean values. In Python you can have a list, I'll call it mixed list, which has a number. We could have a floating point number or a decimal value. We could have a string, and we can have a Boolean value. And as long as they are inside these square brackets, it will still be a correct list in Python. So this is perfectly allowed. As long as we have the brackets, we have commas separating each of the values, we can have an integer, float, string, and a Boolean all in the same list, which most languages, if you try to use arrays or array lists, this is simply not possible. You could view it as an advantage for Python. It means that you can do a lot more with just one single list rather than having to have separate lists for different data types. However, it can also get a little bit tricky or confusing, and you can end up trying to, say, pick a value out of here. Let's say you pick the string and you try to add to it later, you'll get an error because it's a string, not an integer. So it does force you to think a little bit more about the logic behind the program. You have to know what part of your list is a string or a Boolean, etc., because you can't add a number like 0 to a string or hello. So if I run this, at the moment it will do nothing. So we'll save this in our area and we'll call it lists. And it will do nothing. So this is allowed, there aren't any errors, but it doesn't do anything at the moment. So the important thing for all of these lists here are they start and end with the square brackets, and each value is separated by a comma, so it uses comma separated values. If you didn't have the comma there, then that would be a combined 0, 1. Not sure if that will actually give an error or will allow 0, 1. It should do. And from here, we'll move on to printing. So I can print the whole of a list. So I could do print number list, and we will see that that prints everything in the list. So if I do this, it prints the whole list, including the brackets and the commas. So I can print the variable. The variable is storing this entire list of values. And in Python, lists are treated effectively as another data type. So we have our 4 data types. We have integer, float, string, and boolean. Well, lists are considered in Python effectively as their own data type. So this variable is storing a data type which is of list. So if I print type, let's copy that again, it will come out and say that it is of class list. So effectively it is saying this is its own data type, it is a list, and we're printing the whole thing. Now, most of the time you don't want to print the whole list. If you're printing something to a user and they see the brackets and the commas when you're printing something out on the screen, the user will probably be quite confused. So instead of printing the whole list, we might just want to print the first item in the list. And I've numbered these 0 to 9 instead of 1 to 9 so that you can see that the position here relates to the first position, and it will come out as 0. So it says 0. If I change this to word list and I ask for position 0, then it will say hello. So what this is doing is it's saying print, I want to print the variable word list, and we know it's a list, and so instead of printing the whole list, I'm going to say I only want the first part of the list, or the first element, the first item, the first bit that comes before a comma. And to do this, you need the square brackets, which are the same square brackets as the list up here, and then you just enter the location in the list of that item. And lists start from 0. This is common in most languages. Most arrays, lists, even loops can start at 0, not 1. So if I print item 1 from word list, it will actually print world. So hello is in place 0, world is in place 1. And it says world. So you can kind of think of this as in a house, you would say the ground floor is the ground floor, it's the bottom floor, and then the first floor is actually the one upstairs. So in this, our position 0 is the bottom one, the very first one, and item 1 is one step up, 2 would be Python, and so on. So that's the main part of lists that I would say students struggle with, is acknowledging that this does not start at 1. This is not position 1, it is position 0. And we can do this with any of the lists. I can do this with bool list. I can go, let's say 2, which will be false, and we print that and it will say false. So I'm just going to switch to a different list again, and this time I'm going to say I want from element 0 to element 5. Now, an important note about this use of the colon. So we're saying I want to print all of the items from the variable decimal list, which is this one, but I am now selecting only elements from 0, and the colon effectively means to position 5. But this does not include position 5. So position 5, whatever's there, will not be printed. So if we look at this list, we have 0.0 in position 0. That's 1. That's 2, 3, 4, and it will not print this fifth one. So it's printing 0 to 5, not including the fifth element, and the fifth one is 0.5 in this case. So when I run this, you'll be able to see that. So it prints 0.0, etc. up to 0.4. It does not include the fifth one. So again, if you use the colon to say from one element to another, be careful, because if you actually want the fifth one to be printed, then you have to go 0 to 6 instead, and that will now print you the fifth one out. We can do this from a set position onwards. So let's say we want from position 5 onwards. This will print position 5, which is 0.5, and it will print everything after it as well. So if I do that, it prints 0.5 to 0.9. It is printing from element 5, including it, until the end of the list. And you can do this the other way around effectively. So instead of writing 0 to 5, I could just put colon 5. You don't have to write the 0 there, and it will print everything up to that fifth item. So it's not just the case that you can print one individual item. You can print multiple items using this colon element, and you can as well print multiple parts. If you want to print something like this, I should use a comma instead there. So if we want to print the second and fourth one together, then you can do it this way, and that doesn't include the brackets in the print statement. So you'll notice before, when I did 2:5 or something like that, it will print the brackets in the display to the user as well. Whereas if you separate them out in the print statement, you actually type out all of the ones you want, it will get rid of the brackets for you. If you're actually trying to print quite a few of these, let's say 3 or more, then this is not very efficient. What you could just do is you could say 2 to 5, and instead of printing it, you could set that to be a variable. So you could say something like new string or new text equals this, and then you could remove or cut out the brackets and the commas and then print it to the user. But I won't go into that in this video. Lists aren't just there to be pretty and printed. You can do all sorts of things with them. You can loop over them, which I'll cover later on. You can add to them and remove from them, and all sorts of things like that. So that's what we'll look at for the remainder of this video, and then I might do a second video where we loop over some of these lists. So if I want to remove an item from one of these lists, let's go for number list, and we'll do number list dot remove, which is a function in Python, and we will say I want to remove the number 2. So this will actually remove the number itself. It doesn't do it by placement. So although this does happen to be in position 2, it replaces it or removes it based on whether it can find a value or not. So if I do remove 2, and I should print afterwards, that would be sensible, and then print this list, you'll see that the 2 has now been removed. It goes 0, 1, 3, and the 2 has gone. Now if I try to, let's say, remove 10, I'm going to get an error. And it says list.remove x, x not in the list. So it is trying to find the number 10 in this list and then remove it, and the number 10 is not in this list. I can do this with word lists as well. So let's say I want to remove the word Python. I can put in Python there, and now the word Python, when I print out the list, is not in the list. So it says hello world is fun instead of hello world Python is fun. So this shows that the remove function tries to find this value, whatever value you put in, whether it's a string, could be a boolean, could be a float, could be an integer. Any value you put inside these two brackets, it will search for it in the list. If it finds it, it will remove it, it will take it out. If it can't find it, it will give you an error. Now if you've seen the try except block video, then you could surround this in a try except block, so you could try to remove something from a list. If it isn't in the list, you could just print a message out to the user like, this isn't in the list. So you could use this for some kind of game, like guessing the word game, and if they guess a word that is correct, then you could remove it from the list. If the word isn't correct, then you could print something out to them saying this word was not correct, or try again, or some message like that. So that's just one example of what you could do fairly easily with lists. So the next thing we can do, if we want to completely remove everything, let's say we want an empty list now, we can do list.clear, and we'll print word list again. You will see that this is now an empty list. So this is what an empty list looks like. You can create an empty list and it just has 2 brackets. We could also just set word list to an empty list. So this creates an empty list and stores it in the variable word list. So word list equals an empty list, print word list. This will do the same thing. However, for sort of memory management purposes, it is better or advised to use clear rather than just resetting it to an empty list each time. So we've covered remove and clear. So remove removes it from the list, and then we can print the list afterwards. Clear clears the whole list. We can also do pop. So pop does rely on the index, the position of the item, not the actual value. So pop would be good if you don't actually know what is in that position but you want it removed. So pop position 2 will be Python again, and we can see that again it will say hello world is fun instead of hello world Python is fun. I could remove the third one instead, and it will now say hello world Python fun. The word is now gone. You can just do pop on its own, and that will take off the last item. So this says hello world Python is, and it will get rid of the last item, so it gets rid of fun. This is, if you use other languages, pop traditionally, if you use pop, it should take off the last one in the list, and you should be able to say print that. So to look at an example of that, we could create a variable here and say word. So word is now equal to this word list.pop. So effectively we're taking off the top value, which is fun, from word list, and we're putting that value in this variable. And if I now print that variable word, it will print fun. So this is sort of a traditional way of using pop. You pop the end value off the list, you put it into a variable, and then you can print the variable or do something with that variable that you want to do later on. With Python, you don't have to pop only the last value. Again, if I did 2, it will say Python, and it should print Python. So if you want to get a variable out and into a variable, you can do it that way, and that works. So this also does the same thing. So word list.pop -1 sort of comes back from the list from this direction. So if I did, let's say, pop 1, we know that this would get rid of world because that is in position 1. So this is 0, that's 1. If I now pop -1, it actually comes back the other direction, and it gets rid of or removes or pops this last item off. There is no -0, it has to be -1. So this will also take fun. And if I do -2, it will get rid of the is, which can be seen here, and so on. So you can go from either left or right, depending on whether you put a minus sign in front of it. So we can now remove, we can clear the list, we can pop items out the list and print them. Well, perhaps we actually want to add to the list. So we can do word list dot append, and let's say we want to add an exclamation mark to the end, and I'm going to want to print this list. So if I run this now, it says hello world, Python is fun, and we have this exclamation mark at the end of the list. So the append will always append this to the end of the list. So it will add a comma automatically, it will add this value, and it will go on to the end. Now, as I was saying before, in some languages, if you tried doing something like this and the array wasn't large enough, you hadn't specified how many values could be put in the array, this might actually give you an error. In Python with lists, they work a little bit like array lists in other languages, in that when you append a value, it will automatically increase the size of the list. You don't need to worry how many items are in the list or how big the list is. You can just add one on and it will automatically do everything for you. So in that sense, it is quite nice. You don't have to worry about memory management. It just will add on the next word. Now let's say that we don't want to add this to the end. Maybe we want to add something in the middle here. Then instead of doing append, we can do insert. So I'm going to say that at position 4, I want to insert the word very. So we've got position 0, 1, 2, 3, and this is currently in the 4th position. So fun is currently in position 4. Now at position 4, so before fun, but after is, I want to insert the word very. So this is saying insert at position 4. We use a comma to separate the value we want to add from the position, and I'm going to say I want to add very. So it says hello world, Python is very fun. So this is now the 4th one in the list. So first comes the index or the position, and then you put the value. And this will work in the number list as well. So if I want to, let's say, well, we could even do it here. So at position 4, I want to add the string very. Even though that is a list of numbers, it will still work. So before the number 4, it now says very, which doesn't make very much sense. No pun intended. We could change this to a number. So let's say we wanted to add 3.5, and it will now add 3.5 between the 3 and the 4. So again, the first number is a position, and then after that position comes the value that we want to insert. So this is very good because you don't have to just add to the end of the list. We can add part way through the list another value. So let's say we forgot to add a value somewhere up in our program, we want to add another one, we can do that. Or if the user types something in and we want to add that value in the list, we can do that. You can even search for the position. So let's say we did have a list of numbers that the user had typed in and we want them in order. Then you could find, let's say, where this value should sit. 3.5 should be in position 4. Well, you could find that position using some a little bit of maths in the program and insert it at that position so that it remains in order. So there's lots of things that you can do with insertion. We can do pop, we can remove, we can clear the list, we can append to the list, we can also use del, and that largely works just like the remove function or the pop function. So if I do del, which is short for delete, and I take, let's say, our word list and I want to delete position 1, and then we'll print it again, then we will see that the first item, which is world, has been deleted. So it says hello Python is fun. There's a little space there, and that is where the word world used to be. So there are several different ways to remove things from the list. Del has no way of returning the value, so if you just want to delete the value without being able to put it in a variable, then that is fine. You can just delete it, and that's okay. If you want to actually get the value of that element out, then you would use pop. And if you want to search by value instead of by its position, then you would use remove. So we effectively have three different ways of doing very similar things, but they do work slightly differently. The last thing I think I'll show in this video is the ability to count how many of a particular item there are in a list. So let's say we take this bool list and we want to know how many times true has been said. So we could say true count or count true, or however you want to call the variable. There's probably better names for it than that. And I'm going to say count equals the list dot count, which is a function, and it has the brackets as such, and then we're going to put the list we want to count inside these brackets. So we have the list here, which is bool list, the function count, and we're inside the brackets, we're putting the value true, which is here, and then we're going to print true count, and hopefully it tells us that there are 3. And it does indeed say there are 3. So we can use count to count how many of a particular value there are. I could do this for false as well. I won't change the variable name even though I should. And it will now say that there are 2 because there are 2 sets of false, one here and one here. So you could use this perhaps for a survey. Let's say you ask the user to enter whether they give, say, 5 stars or 1 stars on your review of how good your program or your product is, and we can add their input into a list each time. So each time they type something in, it gets added to a list, and then we could use the count function to count how many people, say, gave a 5-star, or how many people gave a 1-star review, or things like that. So again, these sorts of functions and lists are very useful in that sense. So instead of having an if statement that says, you know, if the rating given is 5 stars, then add 1 to a variable that tracks that and then print it out at the end. Instead of doing all of that, if we just add it to a list and then do count, well, that does the exact same thing, but does it in a slightly neater way, where you have a list of all the values as well as what was actually said. So you could also see how many people had replied in total with 5 stars quite easily, and how that compares to the other ratings. As this video is getting quite long, I think I'll leave it there, and we'll look at some other functions like looping over a list or looping through a list in the next video. Thank you for listening. Have a good day.